Hello from Miss Brown. Having a little quick lesson today on DNA. Big day here today at school. We're having a playoff game tonight, so we're all excited about that around here. But today I want to talk to you about this DNA study we've started, and it's called the base pairing rule, or often called Chargaff's rule. And remember, Watson and Crick had a lot of these ideas they put together to make the model of DNA that we understand today. So let's talk about what this means, this base pairing rule. It's a little refresher, I think, for you. Let's remember, if you had, DNA is that double helix, is twisted. So if you open it up, if down one side you have these nitrogen bases. There's one. A stands for adenine, as we've learned. T stands for thymine, and C stands for cytosine. So let's say we had those down the left-hand side. Hold it up where you can see. So what would be on the other side of the ladder? With A, we always have T, thymine. They go together. Remember, at. And T on one side would have an A on the other side. If there was a C on the left, we'd have a G on the other side. Okay, these are the base pairs, how they work. It's sometimes called, if I can write it, complementary. And that doesn't have an A in it. This isn't the kind of compliment like, oh, your hair looks nice, or I love your new car. This is complementary. It means they go together. They complement each other, like complementary angles in math you may have learned about. So that's how this works. Now, Chargaff learned way before Watson and Crick. He figured out there was some kind of connection between these. They knew these were in there chemically, but they didn't really know how they were put together. But he knew there was some kind of combination, because what he discovered, if he had a sample of DNA, and something else I want you to realize, this DNA code that goes down the ladder, it spells out what makes you, you, and it makes me, me, and a tree, and a bacteria, and a fish. It's all the same as far as the components. It's just the letters and how they're put together that spells out human, that spells out fish, that spells out fungi. That makes a little boy, and a little girl. It's the codes in that DNA. It's those letter sequences, what they spell out in that alphabet. So the DNA is not any different in English P than it is in a mountain lion. It's just, it spells out what makes that organism. Okay, so let's talk about Chargaff would have a sample of DNA, and let's say in that sample he might have 10% adenine. Okay, so make my one a little better. If for every A you have a T, if there's 10% adenine, how much thymine T would you have? 10%. Okay. So guess what he found out with the other? What's left? 80%. Well, 40% of that, half of it is going to be cytosine. And for every cytosine, you're going to have a guanine. So 40% of that will be guanine. Well, so if I just gave you 1%, one of these, of the percentages, you should be able to tell me the others, right? So let's practice it. Let's turn it this way so Ms. Brown can write. Let's try it one more time. Let's say, I don't know, let's say you have 20% cytosine, okay? That means you'll have 20% guanine. So that leaves me 60. So half of 60 is 30. So 30% will be adenine, and then 30% will be thymine. Okay, so if I just give you one, you should be able to give me the others, and be prepared to do that on our test when we take it. Okay, all right, thank you, and roar lines.